Welcome to myprojectbazaar.com. Our product title is Implementation of a Laboratory-Based Low-Cost AC Chopper Soft. Let us see about the abstract of our product. In this proposed implementation is based on a laboratory scale implementation of an AC chopper soft starter topology for 3-phase induction motor, which was designed to be used in power quality and in power electronics for students from electrical engineering, and that laboratory such a project proposal from control engineering. The issue of cost was considered as a constraint. Most of the components were chosen based on feasibility of the project and the availability of the local stores. To reduce the required programming skills, the control of this implementation is very effective than conventional control system. The other common solutions are based on terminal voltage reduction, decreasing the locked rotor current. The significant drawback of this technique is that when the motor terminal voltage is reduced, the starting torque changes in quadratic proportion to the voltage variations. In this proposed design is implementation in MATLAB simulating environment. And one important thing in this proposed implementation is only done for the flow diagram basis, because this is the client requirement, so that only we did, and also that corresponding output waveform only here we provide, and these things are done in the MATLAB simulating environment. Next we see about the flow diagram of our product. In this flow diagram totally having 4 blocks. One is the input block, another one is the output block, and another main thing is a converting block, and that converting block is controlled by the controller block. The input block is a 3-phase source, that is 3-phase AC supply. That AC supply is from the grid side or commercial distribution side, or else that AC waveform is fed into the motor. Here we using induction motor. Generally various kinds of induction motor are in. There are squirrel cage induction motor, slip ring induction motor, and so on. So those kind of induction motors here we used. So in this rating we will change, and also that parameter will changes, and that output waveform is depend on the parameters of the induction motors. So here wound rotor motor are used, and in between the input source and the motor side we using AC chopper. AC chopper is nothing but generally chopper is converting one level to another level in a same form of energy. So here we using AC chopper. So here the AC supply is fed into the AC chopper, then that AC supply is further boosted or bucked for record output of the motor, and also here we using IGBT switches, and that switches are controlled by the PWM controller. In the simulation we using PWM controller, but in the hardware wise we using Addons or any embedded related process. Here in this implementation we only did in the simulation, but in also that is only considered in the general values, because some values are not given in the base paper. So we consider general values and apply that instead of that values, then the waveform will be getted for corresponding controlling circuits only. And also in the PWM controller we assign the carrier frequency value and also the modulation index. Due to changing of the carrier frequency and modulation index, the output waveform will be changes, and that will be updated. Next we see about running process of our product. In this proposed implementation is done in MATLAB simulating environment. First to open the MATLAB main window. After that we create a new model file. After creating the new model file, we arranging the elements as per the circuit diagram and also give one flow diagram. From that elements are from Simulink library browser. In the Simulink library browser, we using two major toolboxes. One is SimPower System toolbox, another one is the commonly used toolbox. From that toolbox we getting the elements and then arranging the elements as per the given circuit diagram. After that we arranging that elements, we connected the scope for corresponding measurement devices across. So after connecting that, we click the run icon. That after clicking that, the simulation will be started to run. Then after entered the simulation, the scopes, open that scope, corresponding output will be shown in that scope. So first one is the input voltage and current waveform within the base difference, and next one is the waveforms is getting from before entering the AC choppers and after that connection of mutual inductance. Here the voltage range is 80 and the current range is 5 ohms. So next we connected the PWM generator to trigger the PWM power alternating switches in the AC chopper. So this is the conditions of enable the switches for triggering functions of power alternating switches. So this is the output of the motor, induction motor. Here we using wound rotor induction motor. So the first one is the LM, the unit is a H, and next one is the rotor speed, that unit is a radians per meter, radians per seconds. Next one is the electromagnetic torque TE, and next one is the rotor angle, that is ranges is radians, and next output is the rotor current and also rotor current of IB in terms of amps. Next one the stator current IA, and also next one is the stator current in the IB of IS. So these are the output waveform is getting in the proposed implementation. So we control the motor using of AC chopper. So these are the used in the applications of laboratory sites. Thank you for watching this video.